Dear students, welcome to my new lecture. I am Rokhshana Parvin, lecturer, Department of Civil Engineering, All University of Bangladesh. In today's lecture, we will cover falling head permeability test, mathematical problems on falling head permeability test. Constant head permeability test. The constant head permeability test is a common laboratory testing method used to determine the permeability of granular soils like sands and gravels containing little or no silt. Falling head permeability test. The falling head permeability test is used to determine the permeability of fine-grained soil with intermediate and low permeability such as silts and clays. Falling head permeability test. A standpipe of known cross-sectional area A is fitted over the permeameter and water is allowed to run down. The water level in the standpipe constantly falls as water flows. Observations are started after steady state of flow has reached. The head at any time t is equal to the difference in the water level in the standpipe and the bottom tank. Let H1 and H2 be the heads at time intervals t1 and t2 respectively. Let H be the head at any intermediate time intervals t and minus dH be the change in the head in a smaller time interval dt. Minus sign has been used since H decreases as t increases. Hence, from Darcy's law, the rate of flow Q is given by Q equal to volume V divided time t equal to minus dH into A divided by dt. dH into A represents the volume of water in the pipe and dt is the time equal to KIA. And again we know from our previous lecture that in Darcy's law Q equal to KIA. Replacing I equal to H by L, we can write K by L into A equal to minus dH by dt into A. After rearranging, we can write AK by AL into dt equal to minus dH by H. Integrating between two time limits t1 and t2 in equation 1, we get AK by AL integration t2 t1 dt equal to minus integration h2 h1 dH by H. Here upper and lower time limit is t2 and t1, and this time the head difference is h2 and h1. If we want to change negative signs, we have to interchange the limit. So we have written integration h1 h2 dH by H. Again we can write dH by H equal to 1 by H dH. By integrating, we know integration of dt within time limit t2 and t1 is t2 minus t1, and integration of 1 by H dH within the head difference h1 and h2 is log e h1 minus h2. From this equation we can write AK by AL T2 minus T1 equal to log E H1 by H2. If we write T2 minus T1 equal to T, we get AK by AL into T equal to log E H1 by H2. Replacing K in left side, we can write K equal to AL by AT log E H1 by H2. Again we know log E equal to 2.303 log 10. So finally we have written K equal to 2.303 AL by AT log H1 by H2. The constant head permeability test is used for coarse grained soil, whereas the falling head test is used for less permeable soils where the discharge is small. Let's solve this problem. To find out coefficient of permeability of a clay, the permeability test was carried out in a variable head permeameter having the diameter of the sample container to be 10 cm. That means capital D equal to 10 cm. The initial height of water in this tank was to be 45 cm and it was observed to drop 30 cm in 3.25 minutes. That means H1 equal to 45 cm and H2 equal to 30 cm and time t equal to 3.25 minutes. If the sample be 15 cm high and the diameter of the standpipe be 1.9 cm, determine the coefficient of permeability of the clay in meter per day. So L equal to 15 cm and small d equal to 1.9 cm. We have to find the coefficient of permeability K in meter per day. As this is the clay sample, we will use the formula of falling head permeability test. We know K equal to L by AT into ln H1 by H2. Here given in question, H1 equal to 45 cm, H2 equal to 30 cm, time t equal to 3.25 minutes, equal to 2.25 into 10 to the power minus 3 day. L equal to 15 cm. Small d equal to 1.9 cm. So area A equal to pi by 4 into d square equal to 2.8 cm. Capital D equal to 10 cm. And area A equal to pi by 4 d square equal to 78.54 cm. Replacing all these values in this equation, we get K equal to 0.964 meter per day. Permeability of standard soil deposits. The average permeability of the whole deposit will depend upon the direction of flow relation to the direction of the bedding planes. We shall consider both the cases of flow. Number 1. Parallel to the bedding planes. Here, all deposits are parallel to the earth plane. And number 2, perpendicular to the bedding planes. Here, all deposits are perpendicular to the earth plane. If the soil layers are different and have different coefficient of permeability and thickness, the average permeability will be calculated by these two equations. When the soil is parallel to the bedding planes, then average permeability Kx will be Kx equal to K1Z1 plus K2Z2 plus K3Z3 plus KnZn divided by Z1 plus Z2 plus Z3 plus Zn. Similarly, for perpendicular bedding planes, average permeability Kv will be Kv equal to Z1 plus Z2 plus Z3 plus Zn divided by Z1 divided K1 plus Z2 divided by K2 plus Z3 divided by K3 plus Zn divided by Kn. Let's read the example regarding coefficient of permeability. A horizontal deposit of 3 layers is uniform itself. The permeability of the layers are 8 into 10 to the power minus 4 cm per second, 50 into 10 to the power minus 4 cm per second, and 15 into 10 to the power minus 4 cm per second. And their thickness are 6 meter, 3 meter, and 18 meter respectively. That means these are the values of coefficient of permeability. And these are the values of thickness of soil of 3 layers. Find the effective average permeability of the deposit in horizontal and vertical directions. So we have to calculate Kx and Kv. We know average permeability for horizontal direction. Kx equal to K1Z1 plus K2Z2 plus K3Z3 divided by Z1 plus Z2 plus Z3. Here given in question, Z1 equal to 6 meter equal to 600 centimeter. Z2 equal to 3 meter equal to 300 centimeter. Z3 equal to 18 meter equal to 1800 centimeter. K1 equal to 8 into 10 to the power minus 4 centimeter per second. K2 equal to 50 into 10 to the power minus 4 centimeter per second. And K3 equal to 15 into 10 to the power minus 4 centimeter per second. If we input these values in this equation, we can write Kx equal to 1.73 into 10 to the power minus 3 centimeter per second. Again, average permeability for vertical direction, Kv equal to Z1 plus Z2 plus Z3 divided by Z1 divided by K1 plus Z2 divided by K2 plus Z3 divided by K3. Here, all values are same as used in Kx. And finally, we can write Kv equal to 1.34 into 10 to the power minus 3 centimeter per second. And this is the end of our today's lecture. Thank you everyone.